Hey guys, I hope everyone's doing well. I wanted to go over how to, let me clear this value first. I want to go over kind of what's going on with this project and kind of help you guys get over a certain point where that a lot of people are kind of getting to. I'm going to explain things a little bit to hopefully help you get to the end of this by early next week. So kind of what's going on here. So what's happening with the fractional reserve system? This is how the banking system in the United States works, and really in a lot of advanced economies around the world. What happens? Let's start off with what happens. You have $100,000. You're going to deposit it in the bank, right? So I put that in my Wells Fargo bank or Bank Plus, right? So that's bank one. In that bank, I've got $100,000. So when I go and log in online and look at my account value, it says $100,000. But what does the bank do? The bank is not required to hold that $100,000 in the bank. They're actually only required to hold, in the United States, they're only required to hold 10% of that, depending on the size of the bank. Most of them are required to hold 10%. All right, so what that means is they only hold 10% of this number in the bank. So your $100,000, the bank only has about $10,000 of that sitting in the bank. The other $90,000, the other 90%, they actually lend out. They give that out in the form of a loan to either other people, other companies, or other banks in order to make money. They make money off of loans. So we're going to assume for our purposes that they take that $90,000, your $90,000, and they're going to loan that out to Bank 2. All right, so then Bank 2, what are they going to do? They're only required to hold 10% of that in their bank, right? That's their money. They put that in an account, and they say, I'm going to hold 10% of that. I'm going to loan out the other 90%. What's 90% of 90,000? That's 81,000. They're going to loan that out to another bank, Bank 3. So what we can do is we can extend this a little bit, right? So let's copy this down a few rows, right? They're going to loan out that 81,000 to Bank 3. Bank 3 is going to hold 10% of that as well. Loan out the other 90% to Bank 4. Bank 4 will do the same thing to Bank 5, 90%, 90%, 90%, all the way down, right? And so we can kind of think a couple of things, right? So what's going to happen with this pattern? If I'm loaning out 90% each time, will this number in column D ever be 0? Let me write that out. Will the number in column D ever equal to 0? Well, let's think about that. When will that number be 0, if ever? Right? How can I get a 0 to pop up here? Well, the short answer is it can't, because what's happening is I take this number, right? And what do I do to get to the next number? I'm going to multiply it by 0.9, right? So if I multiply a non-zero number times 0.9, is the next number going to be 0? No, that doesn't make any sense at all, right? That wouldn't be 0. It's still going to be some positive number, right? So some positive number greater than 0, always, because I'm always multiplying by 0.9, right? 0.9. So these numbers will always be greater than 0. They'll never touch 0, right? So what's happening? Let me erase this stuff. All right, so then what happens when I actually drag this row down? This is the point where you guys are getting. If I take this row, these numbers, I'm going to copy them, and I'm going to drag them down, right, to the point where it starts to hit around 0. I think it's going to be right around here somewhere. Paste those values. Let's see. So we go down. Awesome. So these numbers are starting to get into the pennies we're loaning out, right? There we go. We hit 0. So like I said, is that actually 0 there? No, we said it's not 0. We proved that it's not 0. And what you can actually do is go to where you see these little increase, decrease decimal buttons. And then we're going to increase the decimal. Let's increase it out. Boom. There's actually about a little bit less than half of a penny sitting in that bank, right? Same thing here. We can increase these decimals, right? Let's increase those decimals. Still, it's a little bit lower, right? It's 90% of the last bank's value, right? So it's still never going to be 0. At a certain point, though, if we go on far enough, Excel won't be able to calculate past a certain decimal point, right? But does that mean that that the value in that cell is going to be 0? No, theoretically, it's still a positive number. It's just really, really tiny, and Excel can't calculate that. So eventually, Excel is just going to round to 0. All right. So those numbers will never be 0. It's an infinite list. And then how are we going to figure out how much money is in the economy from that? So first, let's write out kind of what we're finding. So let me go back up here. Let's see. So numbers in column D are never 0, all right? And then for the next piece of this, let's figure out kind of how can we figure out how much money is in the economy, right? For my $100,000. Well, this $100,000, I put that in the bank, right? They don't have $100,000 sitting in the bank anymore. There's only $10,000 there. But when I go in and log into my account online and I look at my account value, what does it say? Does it say $10,000 in my account value? No, it says there's $100,000 sitting in my account. That's my $100,000. And if I want to take it out of the bank is obligated to give that to me. So that $100,000 still theoretically exists, right? What about the $90,000 in bank 2? It's the same situation. There's not $90,000 sitting in there. There's only 10% of that sitting in bank 2. They loaned out the other 90%, right? But bank 2, when they look at their account value, they don't see $9,000. They see the $90,000 that's sitting there, right? It's the same situation as my $100,000. Same thing for bank 3. They don't actually have $81,000 sitting in the bank, but they are obligated to have that $81,000. They have the right to that $81,000, right? So that's sitting in that bank. So what we can do is add up all these numbers that are actually sitting in all these accounts. These are numbers sitting in accounts, right? Add them all up and then see what that equals, right? So I told you guys here on the right in step 5 how to do that in Excel with this little sum formula. All right, so some of you guys know Excel. So if you don't, hopefully this is a good little intro for some of y'all. But what we're going to do is we use a sum formula. So I'll go up here. Let's see. I need to go back to, there we go. Let me do it up here. One sec. Let me move this guy out of the way. There we go. All right, so I'm going to go here. I'm going to enter that sum formula. I'm going to say equals. I'm going to type SUM, open a parenthesis, and I'm just going to select column D. And I'm going to close parentheses. So it's going to sum up all the numbers that it finds in column D. Hit enter. Boom. $999,999, basically almost $1 million. All right. So our question is, can I round that up to $1 million? Right? If this list that I'm adding up goes on forever, right? This list in column D, if all these numbers go on forever and I'm adding up an infinite list of numbers, can I ever say just that I can just round it up to some number? Or will it ever pass? So it looks like this is going to be about $1 million. Will it ever pass $1 million? Can I say that it's $1 million, or will it diverge, cross $1 million and go on forever? Right? How can we determine that? Well, that's going to be using our geometric series formula that you learned from Khan Academy. Right, so we have to realize that this list of numbers that we're adding up is actually a geometric series, right? So let's write out that word. Geometric series, right? And if you remember, in a geometric series, you start with a certain number, right? We're adding up a list of numbers. You start with one number, then we multiply that number by some ratio, R. That's my common ratio, right? Multiply by R again to get the next number, multiply by R again to get the next number, and so on, right? And then we're going to go all the way out to n, and that's going to be the sum of the first n terms of that series. And there's a formula for it. If you remember from Khan Academy, 1 minus r to the n over 1 minus r. Boom. That's this formula for the sum of the first n terms of a geometric series. All right, so I'm going to look at this list, and we can spot we can spot that this is a geometric series, because what am I multiplying by every time to get the next number in the list? Well, how do I go from 100 to 90? Right, I multiply by 0.9. How do I go from 90 to 81? Well, I'm going to multiply by 0.9, right? 81 to this number, 72,900. I multiply by 0.9, right? So each of these numbers, to go from one to the other, I'm multiplying by 0.9, and I'm going to add them all up, right? I'm going to add them all up to get the total sum of the numbers of the money that's been generated in the economy, right? So let's write out a formula for our specific situation. What's the first number in my list that I start with? It's the number at the very top. It's $100,000, right? So let me write that down, $100,000. We got 1 minus, what's my common ratio? We said that's the 0.9 to the n power, all divided by 1 minus 0.9. All right, so what does this mean? This means that if I want to sum up the first, say, 5 numbers, right? Well, that would be like me going in here. Erase all this stuff. It'd be like me going in here and summing up the first 1, 2, 3, 4, 5 numbers. Adding them up, that's what this formula does. So I'm going to start with $100,000. Do 1 minus 0.9 to the 5th power divided by 1 minus 0.9. That would be the formulaic way, kind of a shortcut way to add up those 5 numbers, right? If you don't see that it's a shortcut, let's say I want to add up the first 100 numbers. So we'll add up the whole list all the way down to here, right? All those numbers. Well, then you would just do S of 100, right? I'll just write it out real quick. 9 to the 100 power, all divided by 1 minus 0.9. All right? But we're not adding up 100 numbers. We're not even adding up 1,000 or 1,000,000 or 1,000,000,000 numbers. We're adding up an infinite number of numbers. So how can I use this formula to calculate that sum? Well, we're going to have to bring back limit notation. All right, so let's write out our sum formula, my S of n. And then what I'm going to do is I'm going to say, what is that approach as n goes to infinity? Does it approach anything, right? We said it might be $1 million when we actually added up all those numbers that we have in our list currently, right? We said it might be $1 million. It's pretty close, but does it ever cross it, right? This limit formula will tell us that. Is the $1 million the limit, or does it go above $1 million? Well, let's find out. So I'm going to do the limit of this. I'm going to do a limit as n goes to infinity of that sum formula. 1 minus 0.9 to the n over 1 minus 0.9. All right, so the trick here is, what is the variable that's increasing, right? It's this n. It's going towards infinity, right? And so then what piece of this formula has the n in it? It's the 0.9. So we're going to kind of focus in on that and see what happens as n gets big. What happens to this chunk, this 0.9 to the n power? All right, so let's do, what's 0.9 to the 1 power? That's easy, 0.9, right? What's 0.9 squared? That's almost just as easy, just squared, right? 0.81 cubed. It's going to be 0.729. All right, so what's happening? It's decreasing, getting smaller, smaller, and smaller, right? What's 0.9 to the 1 million power? Right, that's going to be crazy small. It's going to be almost 0 because it's so tiny. What's 0.9 to the 1 billion power? That's still not going to be 0. It's still going to be a tiny, tiny positive number, but it's going to be very close to 0, right? So we can kind of keep this trend going and saying we're going to get really, really tiny numbers as n goes to infinity, right? So as n goes to infinity, my 0.9 to the n goes to 0. It approaches 0. So I come up here and I say, well, this limit, this guy is basically 0 as n goes to infinity, right? So we're going to say that's going to basically be equal to $100,000 times 1 minus 0 divided by 1 minus 0.9. And then what is that equal to? That's equal to an actual number. All right, $100,000 divided by 1 minus 0.9 is 0.1, which is the same thing as multiplying by 10. So $100,000 divided by 0.1 is the same thing as multiplying by 10, which is going to be 1 million. So $1 million, well, we were kind of seeing up here from our Excel formula, right? Our sum formula, this guy up here. We saw that's almost $1 million, right? But you can kind of see it if we extended this list even further, right? We'd see that this number would get bigger and bigger and bigger and closer to 1 million. Eventually, Excel would just round it to 1 million, right? Because it doesn't want to keep doing those calculations. It can't keep doing those calculations forever, right? So we just showed mathematically as well that the limit is $1 million given our current situation, given our common ratio here and our initial value, right? So what this project is going to ask you is, what happens if we change some of our inputs? What happens if we change, let me erase this. What happens if we change this 0.1, this reserve ratio? So remember, that's the amount of money that the bank's required to hold, which means that they're going to loan out 1 minus 0.1 they're going to loan out 90%, right? So that was the amount that they're loaning out to each bank, 90%, right? So that 0.1 is determining what these numbers are in column D, right? So the project's going to ask you, well, what happens if I change that 0.1 to like a 0.2 or 20%? Is that going to give me more or less money in the economy? If the banks are required to hold more money, right, then does that generate more money in the economy or less money in the economy, right? And so what does that boil down to? It boils down to this limit formula, right? So what would happen is this number would change. The 0.9 would change, right? And then this 0.9 down here would change as well. And so then if we just modify those couple of numbers and then recalculate this, we'll get a different number other than 1 million. You'll be able to see, does it increase above 1 million or decrease below 1 million? Am I getting more money out of the economy or less, or I'm sorry, am I generating more money into the economy, or am I generating less money into the economy from that initial $100,000 by changing that 0.9 to something else, or the 10% to something else?